Welcome to another video as part of the Pavilion video series, a demonstration of what happens when a controller fails and the performance impact that has on a VMware host. I am Kostas Apopoulos, the Chief Field Technology Officer and Worldwide Vice President of Business Development. I'll be joined by Phil Aronowitz, one of our Principal Solutions Architects, who will actually be giving the demonstration. In this demonstration, we're going to show one of the really unique high availability features that Pavilion has. And this is enabled by our multi-controller architecture. As you know, we're not a dual controller architecture. We are a many controller, up to 20 independent storage controllers. Those controllers can be used from an HA perspective kind of uniquely. Of course, they can be used like everybody else, where you have an active and a passive. Now, in a typical environment, you have a dual controller system. So you have one's active, one's passive, and one's active for one and passive for the other. In our scenario, we can have many controllers. So we're going to start with 5 controllers, and we can set that up in an active, passive, kind of round-robin approach. Controller 1 has its own active workload, and it has a failover controller of controller 2, which has its own active workload. And this is demonstrated by the A in the green and the S in the gray. 2 has its active workload, and it can be failed over to controller 3, which has his own active, which goes to 4, 4 to 5, and 5 back to 1. Very similar to anybody else in the environment. As you know, in those scenarios, since one controller has its own workload and the controller it fails to has its own workload, you have to be a little bit careful about how much workload you assign to every single controller. Because the sum of the 2 workloads, if one fails over to the other, could be more than 100%. So kind of a best practice, you got to be careful. Something less than 50% is probably what you should do. Now, because of Pavilion's multi-controller architecture, we have a technology that we'll call it controller RAID. In other words, we can have 4 controllers that all have their own active workload, and one extra controller is there sitting there warm in case one of the other controllers fails. So in this scenario, 6 has its own active workload in green, and its failover controller is 10. 7 has its own active, its failover is 10. 8 is 10, 9 to 10. 10 has no active workload. So in this scenario of failure for controller 6, its active workload moves over to 10, which has none of its own active. So the performance characteristics will be the exact same after the failure as it was before the failure. That allows us to do something very unique in the industry. So with that, that's what Phil's going to demonstrate in the video. So I'll turn it over to you, Phil. Take it over.
We'll be demonstrating the impact of a controller failure on a Pavilion hyperparallel flash array. Here we have an ESX server running ESXi 7.0 U2 with 4 data stores provisioned from the Pavilion hyperparallel flash array via NVMe-RoCE. I have a number of pre-staged CentOS images. For the sake of the demo, we'll be using CentOS 50GB1, and as we can see, this host is provisioned on ESX DS4. Over on our array, we can see ESX DS4 is mapped with its primary path to controller 4 and its second path to controller 5, and we see it's currently active on controller 4. To demonstrate the impact of a controller failure, essentially what we're going to do is run some FIO jobs on one of the CentOS images attached to ESX DS4, and then we're going to shut the controller down, forcing it to fail over to controller 5. Over here we have our CentOS virtual machine, and I have pre-staged an FIO job that is going to be running a 1024K block size with 16 jobs, essentially 16 threads. So let's go ahead and kick that job off. And we can see that we're getting about 6 gigabytes of throughput per second. So now what I'm going to do is over in the Pavilion UI, I'm going to go over to controller 4, and I'm going to power it down by clicking the button right here. So let's go ahead and do that. And we'll see we have an immediate pause in I/O running against the CentOS virtual machine. If I go take a look at the block volume, we'll see now it's active on controller 5. And in a moment, VMware's MPIO will fail the volume over and I/O will continue. So now we see a resumption of I/O to approximately 6 gigabytes per second. That took under a minute. And we're now running at full throttle on the failover controller. Thank you.
Thank you for watching this video as part of the Pavilion video series. If you want to learn more about this topic or others, check out our other videos at www.pavilion.io. You can also reach out to us via email at info@pavilion.io, or you can always call us on the phone. We'd love to talk to you about how Pavilion can help you solve some of your most challenging storage-related problems and help you deliver incredible business outcomes to your customers. Thank you.